Okay, Arvind.
I think it's time. So once again, welcome. Thank you for your participation in this session. We'll make sure it's worth your while. And again, thank you for being here in person. For me, it's my first pass after a gap of almost 3 years. The pandemic and then things being all remote did not help either. So I'm very, very glad to be back in person and having this opportunity to share with you some of these capabilities and new announcements that we have to make. For context, I think we all live in a world where we know that innovation is the key to driving growth in your business and growing your customer base and overall, that innovation is the key thing. As you have been seeing AI, all these revolutionary tools that are being made available today are the key to success. You want to add capabilities to your offerings and so on. Data is at the heart of AI, and most data lives in databases. So at the heart of it all is you want to grow your business, you want to use databases to power that growth, but also in today's challenging economic times, at the forefront of it all is how are you going to do, how are you going to keep your costs under control. So in our session today, we are going to share with you some capabilities and some new announcements that we have to make, both on the performance optimization front, but equally so on the price optimization front. And we'll show you how Azure SQL Hyperscale allows you to land that right balance of price and performance for your new workloads in the cloud. My name is Arvind Shamsundar. I am a program manager at Microsoft. I work on the Hyperscale product management team. And my day job is to deliver new capabilities. I specifically work on something called Elastic Pools for Hyperscale, which we will cover later in this presentation. And it's one of the tools, of the many tools that are in your bag to drive the best price performance point for your database workloads in Azure.
And I'm Aditya. I'm also a program manager, product manager for Hyperscale. I kind of look at the core of Hyperscale product and the price performance aspect of Hyperscale product. So now that we have got the details of the session, let's really talk about you. Okay? How many of you are a developer? Show of hands, please. Developer. Okay. Okay. How many of you are an architect? Okay, a lot of architects. Administrators. Yay, my favorite gang. And managers. Okay, I will be careful with you. And how many of you actually used SQL DB till date?
Okay, that's great.
Awesome. And how many of you use Hyperscale today? Okay. We'll make sure we will have a lot more hands up by the end of this session. Because my goal and mine and Arvind's goal here essentially is to convince you folks that Hyperscale is the best database. I'm saying best database in the entire cloud world today. And we are going to tell you how to really optimize, price performance optimize this Hyperscale. And we have great announcements that we are going to make with you folks today. Also, I request you folks to stop us while we are talking and ask questions, whatever questions you have in the between. Let's really keep this interactive. We are friends, right? Are you sleeping? We are friends, right? Yes. Awesome. Cool. Now, to really start with, Hyperscale is the cloud native database. What exactly I mean by cloud native database, right? So it is the database which is actually built. You know the SQL Server, right? We used that SQL Server. With ground up, we actually made it as a cloud native database. All the power of SQL Server for the cloud native database. It's the distributed architecture where storage and compute is completely separate. You can have a storage from almost 10 GB to 100 terabytes, from 1 core to 128 vCores. We also have multi-tiered cache to really support all this, to really push the performance of the Hyperscale. Now, this is scalable. Not only you can scale up to 128 vCore, you can actually also scale out your database to 30 named replicas for your query workloads. So all this is to make sure to tell you again, Hyperscale is the world's best database. To really see what is making this world's best database, what is actually making it world's best database, is this architecture. These are page servers, this is compute, this is the actual storage. Man, what's all this, right? Actually, this is nothing. This is what I told you previously. It is the tiered memory architecture. You have your memory, hot memory on the compute. You have your hot memory on the page servers. You have a permanent memory on the actual durable storage. Now, let me tell you why we really want this. If you have a database of 10 GB, you can have your MDF and LDF. But we don't know how much database you will have. It is automatically scalable to 100 terabytes, right? So we actually tiered your database to accommodate 10 GB till 200 TB using this multi-tiered architecture. And this will push the performance of Hyperscale like no other. Don't take my words for it. Our customers, they are there across industries. You can take health, you can take gaming, you can take education. Most of these customers are out there who are using Hyperscale today. And while I'm saying Hyperscale today, these are the customers where you have case studies out there in Microsoft.com. And there are so many other customers who are taking the power of Hyperscale, like IoT data is out there in Hyperscale. And there are few references from our customers. And particularly, I like Matt, who from Revenue saying Hyperscale can significantly increase the number of deployments and expedite the testing process. Not just that, there is one more customer who says we can use the graph query capabilities in the Hyperscale. What is this? Like, you can use graph query capabilities. You can go for 1 core to 128 core. That's why we are saying this is the best database, not just because of the technology we created. It's also the technology that the customers are using today. Hyperscale is there since for a while. It's like since 3-4 years we are running with all these customers. Now, we have so many updates that we actually got in recent past. For price performance optimization, we got premium series and memory optimized premium series. Arvind is going to show us some great demos around that. And we have serverless autoscaling. I'm going to talk about serverless autoscaling in detail. We have elastic pools. We are going to touch about that. We have availability and resiliency updates, like Peter backup, point-in-time recovery backups are there, and you can have till 35 days. You can configure LTR backups. You have zone redundancy support. You have geo-replication and failover, and many things to name up, which means the real reason why we have this slide up here is to tell you folks that the amount of innovation that we are having on this product day to day. Now, I kind of convinced you folks that this is a great database, right? Yes? Yes? Awesome, thank you. I have a question for you now.
Sure.
Because this is a super awesome database, this is for sure costly, is it?
Let me tell you some more details. We have some exciting news that we announced today. I think many of you hopefully had a chance to look at the keynote from Shirish. And if you were part of that keynote, you would have heard him quote some upcoming price changes that we announced today. They're taking effect in the middle of December. So before I get into the details, just to reinforce the points that Aditya made, Hyperscale is real. It's being used by a variety of customers for a variety of workloads and for a variety of database sizes. It's not just for like the ultra big databases out there. As he said, you can go the whole gamut from 10 gig databases all the way up to like 100 terabytes. What would make it even more compelling for customer to use this great technology is at the right price point. It's not just the right performance, but at the right price point. So with the new simplified pricing that we announced today for Hyperscale, we are doing a couple of things to make it easier and even more compelling for you to use Hyperscale. The first thing we announced is that we are dropping the price of compute associated with Hyperscale. Previously, if you were a customer or if you are a customer of Azure SQL, like many of you are, you know how much you have to go through to just leverage discounts. For example, you might have to go buy SQL licenses just to be able to offset the cost of your compute by applying hybrid benefit and so on. So we're doing away with a lot of that, and we actually dropped the price of hyperscale compute by up to 35% in many cases. Now, these costs will all add up, as you will see in a pre and post comparison that I have for you in the next slide. And generally speaking, when we looked at the broader spectrum of our current customer base, we found that in totality, if all these customers suddenly started using this new price model, they would actually see a net savings in price. So it's not just that it's only for new customers. We are also aligning our storage costs with the value that it brings. Aditya talked about the multi-tiered cached storage that we provide. That storage cost actually previously was not reflecting the value that it was providing. Storage cost will go up from the old cost to 25 cents now per gig per month. This is actually the same cost that we charge for other offerings in Azure SQL DB. So there is a net potential increase in your storage costs, but when we do the modeling of the current kinds of database consumption that we have, we firmly believe that your overall costs in many cases will actually be lower with the new pricing model. We still maintain our stand on not charging for I/O operations. This is a very key component. No customer wants an unpredictable bill. Today being charged, let's say, close to no money, and tomorrow, because their workload got really chatty and started using a lot of I/O, their bills would go up. We don't want that, and we never had that. We continue to abide by that principle. So no I/O operation costs. You pay storage costs based on the size of your database, and that's it. So this is, we believe, a more predictable and a simpler model, especially with the compute cost dropping, which should make it even more price-wise, more compelling for you to adopt hyperscale. So it's full-featured, it has great perf, and now it's at a very, very good price point. These changes are not going into effect immediately. We have a 30-day period after which it starts taking effect, at which point in time you'll see these new prices reflecting in the pricing page, pricing calculator, and in the portal. But if you wanted a quick preview, let me show you a screenshot in a minute, but there are blog posts that we published today which actually have a lot of details. So this is a covering blog post from Asad, who's our CVP, and he talks about the value that hyperscale delivers, and at some of the details around the philosophy, why we are changing this price. There is also a more detailed price-related blog post, which you can take a look at some pre- and post comparisons, just to convince yourself how these prices will look in scenarios like yours. Here's a little sort of a mock-up, just to see how prices would look. If you go to the portal today, and you look at the total cost of your hyperscale database, here is an example with 12 vCores, hyperscale, provision compute, costs around $2,400 something in East US today. If you look at the same configuration and you're trying to provision a new database when the new pricing goes into effect, you'll see a reduction in cost by $800. So that's a fairly significant cost. The fine print, of course, and in full transparency, your storage costs do go up in the new model, but in general, again, given the smaller component in general of storage costs, we firmly believe that overall your costs will be much more competitive compared to what they are today. Plus the ease of saving on these costs, right? You no longer have to buy licenses just to be able to offset the costs of this compute. So there are more details in those blog posts that I linked to. I can bring those up if you want to take a photo. Slides have been uploaded to the PAS website, so they should be made available to you shortly. But do use these short URLs if you want to know more about these announcements. If there are any questions on the price, I'm happy to take that now or even offline. So just a quick checkpoint if anyone has any feedback, questions. Yeah.
So with the compute and storage, so let's say that you start with the 32 vCPU core and 10 terabyte storage.
Okay.
And then over the time you grow and then 10 terabyte becomes around 70 terabyte.
Okay.
In this case, would compute increase in number or it will
Okay.
still remain the same? Like is it decoupled or it goes hand in hand?
Thank you, Surbhi, for that question. The question, for the purpose of the audience, was, I'll paraphrase it for simplicity. Is there a tight coupling between the amount of vCores that you have to provision to be able to use the 100 terabyte of available maximum storage? The great point about it, as Aditya mentioned, is these are completely decoupled. Unlike, for example, in other editions of Azure SQL, where to be able to get even 4 terabytes of capacity, which is the maximum available in those editions, you have to be at 24 vCores or more. With Hyperscale, you could have an 8 vCore database or a 4 vCore database and still potentially use up all that 100 terabytes of storage. So there is no tight coupling, and you can definitely scale your compute completely independent of the amount of storage that is associated with the database. Hopefully that clarifies. That's
yes.
true.
Yes,
That's
yes.
True. Yeah. So the question again was, with these pricing changes, is anything changing on the decoupling? Nothing. No. The feature set remains the same. In fact, we'll continue innovating. We'll continue adding features, as we already showed you. We truly believe we wanted to make Hyperscale as accessible as possible to developers, to IT setups of all shapes and sizes. And by removing this, by dropping the compute price, it's a giant step in that direction, I believe. And if you had any hesitation at all, just because of the price in the past, to use Hyperscale, I am hoping that we sincerely hope that this is a major step to help remove any concerns that you might have had previously. Any other feedback, questions? How many of you feel this is a good thing? Any? All right, so hopefully more of you feel that way after you read through some of these specifics and look at this in action. We are not trying to undercut anything. We are not trying to, like skim on any features. It's the same full-featured database behind the scenes. It is the right step in the direction to help you achieve the best balance of price and performance. Okay, another announcement. This is perhaps equally important. If you wanted to further optimize your costs, one popular technique to optimize your compute costs is to do something called reserved capacity. So you kind of prepay, and this prepayment can be amortized over a period of 12 months. So you kind of commit to using a given amount of compute capacity. So you buy vCores ahead of time, essentially. But because you're buying it ahead of time and committing to using that, the rates at which those compute offers are made available to you is significantly lower. We had compute reservations available for Hyperscale in the so-called standard series hardware. So as a quick point-in-time check, because we will talk a little bit more about what we mean by premium series hardware and so on in a minute, but Hyperscale has 3 forms of hardware offers, if you may, behind the scenes. There's a standard series, then there's a premium series, which incidentally is priced the same as the standard series, but it's available in a subset of the regions that Hyperscale is broadly available. And then we have something called the memory optimized premium series. Previously, you could only do reservations for the standard series. Announced today is reservations for premium series and MOPRMS, which is memory optimized premium series. Again, this can be a significant savings to your bill overall, because most of you, we are hoping, are long-term. You are in it for the long term with Azure. So when you're in it for the long term with Azure and Azure SQL DB, reservations are a great way to save money even further on the compute size. So reservations are available today for premium series hardware for Hyperscale. This is available currently in a 1-year package format. Eventually, we'll see if we can make available 3-year RI or 3-year reservations in the due course of time. This applies to any single database you create for Hyperscale. And again, hold your breath, because we're going to talk about pools later. We also have reservations available for elastic pools for the same type of hardware. If you had reservations already today, how many of you use reservations today? Any quick show of hands? Wow. Quite a few of you. So you can exchange the reservations. You can do self-service exchange. If you had Gen 5 reservations, standard series, you can do self-service exchanges for those. Yes, there's a question at the back.
So some of the Gen 5 generations, I don't know if I did a web form here, you can confirm, they don't have temporary storage.
Can you repeat the last?
Gen 5 series generation that just came out right this year don't have temp storage.
Oh, those are VM
those are
reservations.
VM-based stuff.
Yeah.
Yes, but like, how would you then,
it's.
Like, what would be your recommendation in terms of like going to these virtual machines? Like,
Oh,
buy
okay. Sorry.
storage, even though that it could be like less expensive than the ones that has storage.
Okay, I think there's a slight disconnect. So we are talking about the SQL database platform as a service offering. I think what you're referring to is the EB5, the VM offers that PAM, for example. So slightly different, models of databases. That one is IaaS running on compute VMs. This one is PaaS running on our managed hardware, if you may. So slightly different ball game.
Well, but plug here, Pam has a session exactly discussing about that.
Actually, I have the
Yeah.
session on VMs.
Yeah, so
Yeah. Microsoft and we do a great job of overloading terms. So V5, Gen 5, sorry if that kind of was confusing. Sorry for that. So this is self-service exchange for SQL DB reservations. Specifically, there's a different type of reservations for SQL DB, and those can be exchanged only with other SQL DB reservations. Yeah. So as long as you have any type of Azure SQL, like you had, let's say, general purpose Gen 5, you could potentially do a self-service exchange for hyperscale premium series, for example. And the best part about it, I mentioned this, I think, briefly, but I just want to reinforce, the costs of hyperscale standard series hardware is exactly the same as hyperscale premium series hardware. You may ask then, what's the catch? Why shouldn't I use premium series hardware? It's actually, to a certain extent, it could be regional availability. Premium series hardware is available in exactly 23 of the total number of Azure regions, which are like, I think, 50 plus, I think, at this point in time. So that could be a variable, but otherwise, it's actually a no-brainer. You should consider deploying to premium series. Okay, so hopefully this gives you a lot more motivation to try out Hyperscale if you have not already tried it. If you are on Hyperscale, do give it a shot with these newer hardware types. As I said, there's really not much of a implication in going from standard series to premium series. With memory optimized premium series, there is incrementally higher costs involved, but that should not be, hopefully when you need that kind of capability, as you'll see later in my demo for pools on memory optimized premium series, you will know why that value is higher, why that price is higher. So with all this money I'm going to save, Aditya, do you have any suggestions on how I can put it to good use?
you can write me a check though.
Oh.
But jokes apart, I really have to appreciate this, right? So what you essentially just said is we are reducing the cost by 35 up to 35% starting from December 15th.
That's right.
That is huge stealer.
Yep.
The second part I really loved is the price for standard and PRMS is exactly same, and I can just upgrade to PRMS and I can get the better price, better perf.
Better perf at the same price point.
Wow.
So some of this may sound like there's a catch, there's a hidden trap. Please be reassured, this is not a hidden trap. Premium series hardware is the best bet you have for performance at the same price point. So hopefully that reinforces the point that I made.
Yeah. So while Arvind is busy writing a check for me, there is the one serious thing that every one of us, while we are deploying, however cloud native database it is, however it is, one of the things that we really need to make sure is we really put our application at a place where it is highly available. We have how much ever we are having the best cloud native database, building a highly available application is real important, and doing that so way before you configure it is the most important thing. Now, Hyperscale actually gives that ability of creating a high availability replica out of the box. You need not do anything. Go to Azure portal while you're configuring Hyperscale. Just say, I want a HA replica. And that's it. Because we are a distributed storage nature, we will get you a HA replica in a different zone. Now, that is really necessary for failures like zonal failures. And to be really, if this diagram is looking super simple, and I see so many administrators out there, if you want to really geek a lot, This is actually happening out there. You have your services deployed, log services deployed across multiple zones. You have your page service deployed across multiple zones to just make sure that you have your data available always with highly performant caches. Now, while it is very clear that high availability replicas should be there, and we can use these high availability replicas and everything with the same price optimization, right?
Yep. So yeah.
Exactly. So we can take use of the same cost of 35 up to 35% low price for all these HA replicas. Where else we can take care of this? We can take care of this in named replicas. Let me take a bit for explaining named replicas, right? So you have a application, you are writing a lot of data into it. Now you have so many other customers like HR team, finance team, I want to know the data. And also you have AI, where you want to get all your AI data written, read somewhere, and read from somewhere, right? So what it is really a good practice to offload that to a separate named replica. Now you write your application data into your primary database, and you offload all your read stuff into named replica. Because it is sharing the same storage, and it also uses the same SSD caches. It also uses you can actually monitor and independently scale these named replicas. Also, I guess you can use MOPRMS kind of hardware here too?
Yes. The beautiful thing about named replicas is because they're individually identifiable, they're individually scalable and configurable. They can be other hardware types. So for example, if I had analytical workloads that I want to run only on the named replica, I can configure it with memory optimized.
Can I run my AI?
You can.
Okay,
and
cool.
You can run any kind of workload that needs that additional memory, as we'll see in upcoming demo
Awesome.
later in the deck.
So for named replica, means that client can directly connect to that.
Yes, yes. Let's say you have a Power BI app, right? You can actually give that Power BI app the name of that app to be this named replica. That's it.
So now in that case, like let's say one scenario that you have 3 databases.
Uh-huh.
So cross
You can repeat the question when you're done.
Uh-huh.
2 databases, 60 terabyte each, you put that on Hyperscale.
Okay.
Now those 2 databases are there on that Hyperscale, and one of them is having these named replica. Or
Cool.
let's say both of them are having named replica.
Cool.
But now the consumer on the read-only side, they want to do some cross-join. Can they do that on the read-only side because they have like some of the business requirements?
Sure.
So far in the loop, nobody else had to do, but on the right.
Very good question. So if I repeat Surbhi's question again, so what she's saying is, customer has.
Watch out on the edge.
Oh, sure. Customer.
I'm keeping an eye. Sorry.
Yeah, excitement. So customer has 2 databases in primary region. They have got the named replicas. Can they join the read queries in those named replicas? They sure can. They can.
But, sorry, I want to make sure I be completely. So these are 2 distinct DBs.
Databases.
2 distinct databases on Hyperscale, 40 terabyte.
Okay, and,
Yeah, yeah.
and you have a single query that's doing a.
Yes.
But on the named replica, the read-only consumers,
Uh-huh.
they want to write a query which would do the join.
Yes,
Between the 2 databases, so we have each database is completely isolated.
Isolated.
So none of the semantics of Azure SQL database, which is each database being completely isolated, and that still remains. I may be.
You mean cross data join in the tables, or 2 different replicas? you
Not
mean?
in the context of the same SQL query.
Okay.
Is that what? Okay. Yeah. We still can't do that.
We still can't do that 2 different named
Right.
replicas.
And the usual pattern we use for that is you'll typically have a compute outside of the SQL database. So what we've seen is people like analytical workloads, like whether you're using Synapse or Databricks, they will connect to SQLDB and then do whatever cross DB joins in the
App
in
side.
the dedicated kind of analytical compute. The Hyperscale doesn't change the semantics of
Azure SQL.
each database being independent and isolated. We still don't unlock, for those scenarios, of course, you have other offers, right? Like you have managed instance, which can do some of that stuff and so on.
We have already isolated databases. My assumption was that on primary they stay isolated, but maybe on
No. Because they will be different named replicas altogether, because every distinct database, its own named replica, it is distinct, you can't,
The great thing about named replicas is you can spin them up on demand. So if a data scientist group wants to have a dedicated endpoint to connect their Jupyter notebooks or let's say Spark cluster or whatever they want to do for their experimentation, they could spin up a named replica, or the IT behind the scenes could spin up a named replica and tell the data scientist group to connect to that endpoint. So it remains independent. It shares the same backing storage, but because it has its own compute and local associated cache, it'll not affect the primary workload. That's the main value prop, and it can be sized independent of the primary replica. So if the primary may be optimized for OLTP and it's let's say 24 vCores or something of that sort, the named replica could be a memory optimized premium series with 80 vCore or a 128 vCore premium series database and so on. And you could tear that down after the fact. Like if the data scientist project is over, they no longer need the named replica, they can just delete that database and you further keep your costs.
And the beauty of it is you can have not just one, you can have 30 named replicas. You can also have, for this named replicas, HA replicas.
Yeah.
You can have that. So that essentially gives a very good scenario for a scale out scenario. Now, let's talk about one step further. Yeah, go ahead, sorry.
Yes.
Yes.
Yes. Correct.
Yes.
Correct. So the question again for the mutual purpose of the audience is named replicas are in region only. If you needed a cross region sort of a replica, you could do something called geo-replication. And again, that's a capability that's available for most of SQLDB. It's available for Hyperscale as well.
Yeah.
With the current limitation being you can have one of those geo-replicas per database. That is
yes,
true.
That's
true.
And everything is separate. Storage is same. So because you are sharing the storage, the storage costs same. Only the compute costs are different.
The storage cost is paid for already. With the
primary replica.
Yeah. So I think just for mutual convenience, everybody hopefully understood the billing semantics of that. With a named replica, you only pay for the compute. The storage is already paid for in the form of the primary database. So this is a great tool to offload analytical workloads without having to make a copy of your data and without having to pay twice the cost of the storage just because you needed another copy out there.
And for more geo-replication kind of questions, my colleague Rajesh is here.
Yeah,
so
Rajesh,
he has a theater session and you can actually talk to him.
Yeah.
Cool, awesome. Now let's talk about one step further of optimizing this price. So while we have the workloads where you can go from 8 cores to 80 cores, so 1 core to 128 vCore. Consider a scenario, right, where you are a developer and you started your application right off the bat, and now today you just don't know how large you can scale. All you know is ballpark. Maybe I want 24 vCores, maybe I want 36 vCores. That's if you have that ballpark, all you can do is go to Azure portal, choose the serverless option, make your ballpark as whatever ballpark you have. I have got the ballpark as 10 and minimum vCores of whatever you want, and just say go. And Hyperscale takes care of it. What if your workload is increasing, and if your workload is going from, let's say, 0 to 24%, only your 2.4 cores is used. And if your workload is going from 60%, 0 to 60%, it will use only 6 cores only, which means it gives the power for the customer to really be used for the billing. The billing will be for what they actually use, not more, not less. So this is a wonderful opportunity to really optimize the price perf in the Hyperscale. So let's recap what exactly serverless can do, right? Serverless, it auto scale of compute, and which means you can go from, as I showed before, You can go from 1.25 cores to whatever 80 vCores. You can go take your log throughput. Your log throughput is independent of what your scaling of compute is. You can go till 100 terabytes for this serverless. And again, your billing is completely for what you exactly use. Also, we have in the private preview the auto pause or resume. Any of you folks are interested in that, please let us know. We are happy to enroll you into the private preview. So auto pause or resume is very important for serverless, and that's what we have for serverless. Now that I have given few of the tidbits where what we can do as a best practice for H replicas and named replicas, we have good questions there too. Okay. And we also know what we can do with these single databases.
Right.
Let's say that developer is SaaS,
sure,
and I have multiple databases. How are there any tips in your bag to
Definitely.
optimize?
So this is my core area of focus, which is price performance optimization for a fleet of databases, for a group of databases. Before I get into that, though, I do want to reinforce a few things related to the price drop as it applies to serverless. Serverless compute, as Aditya mentioned, is built in an app-second manner. So it's basically what you use, but for that second, the amount of vCores that was provisioned by the engine automatically as your workload behaves. So those app-second billing for hyperscale serverless is also being reduced as part of this price change to reflect the fact that we are saving on compute. So just an FYI, I didn't mention it explicitly in the previous slides on price change, but you will see that drop reflecting in the serverless pricing as well starting December 15th. So again, even more compelling, if you have a workload that's just starting off and you have no idea about what is the right size of vCores and compute to be allocated to that, December 15th, you'll see the value that serverless brings to the table. It's going to have that decrease in price as well. Any questions? Sorry, again, yeah. Okay.
Are optimized and checked, and then the disk, the storage
yeah.
that we going with it is optimized, then checked, and then of course, like the bandwidth going in the other meter categories would also be checked.
That's true. Hey, you want to take a stab at answering this?
So
I think.
So if I understand your question, you would want to start with, you would ballpark your cores to whatever 10 to 15, that is checked, and then storage is checked to whatever it is 100 terabytes. Like what exactly you are getting to? I'm sorry, I didn't get that.
So I was just trying to understand if that would be like in terms of, because AWS has a tool that truly right sizes.
Okay.
Checks the performance of the virtual machine compared to a cheaper virtual machine.
Oh, okay.
Compromise the actual performance for clients that are complex.
Okay.
Got it.
Not penalize the client, and also if it's
Understood.
it's like, proposing that optimization, it's also proposing a virtual machine that's available without downtime.
Okay. So what you are asking is this any kind of a optimization advisory tool where it says optimize to this? Actually, it's not that. Actually, what it is if your workload is, let's say, you are going from 5 users to 15 users, 15 users to 100 users. Without you intervening into it, you need not do anything. Serverless will take care of expanding it to whatever max number of cores that you have asked for. That's what it will do. It will not really say, hey, it is good, your ballpark would be 8 vCores. It will not suggest. It will only act till how many cores it can expand to based on your workload. Did that make sense?
I think so. I can try to paraphrase and try to reinforce the point that Aditya is making. Serverless is a slightly different model of trying to offload some of the complexities for an admin. For example, in the past, like the examples you gave of a VM and a recommendation engine that is telling you, hey, right size this to n number of vCores and so on. With serverless, we are doing that behind the scenes transparently and actually scaling and using the right amount of vCores that the workload needs at any given point in time. In full transparency, the app second billing for hyperscale or for in general SQL database serverless is incrementally higher than if you were to stay with a provisioned compute. But the challenge in the provisioned compute model is if you don't know what is the right size, then you have to rely on an external engine like the recommendation service that you described. We do have some capabilities with Azure Advisor.
Yeah,
I don't know if Azure Advisor.
Pam would have more ideas around
for the compute
right
side.
SKU recommendation stuff.
The whole idea is serverless wants to try to, I mean, we want to try to offload some of that responsibility from you to the service, and it will do the auto scaling. So especially when you have an unproven, unpredictable workload, serverless is a great starting point, and you will see the run rate at which it's operating. So you'll see over, let's say, busy weekdays or whatever, it's typically hovering around the 6-week or used mark, like the demo that Aditya showed. And then you could take a call at some point in time saying, I'm going to switch from serverless because I know now my workload almost always is hovering above the 6-week or mark, and I could switch to a provisioned compute model, and where you will pay all the time for 6 cores, even if the workload dips well below that. But then the per hour rate with provisioned compute is incrementally cheaper than with serverless. Serverless, with the flexibility that it gives you, it does come with a slightly higher compute cost per second. So when you have unpredictable workloads which you don't know what is the right size, serverless is a great starting point. And over time, as you get more aware of the workload characteristics, you could switch that on the fly, literally minutes. You could switch to a provisioned compute model and stay there. Does that help? Sorry,
Yes.
there's a question here.
Probably just a general question for serverless. Do you guys have other throttles that are associated with the number of cores, like your IOPS, your memory, max concurrent connections, all that kind of stuff? Does serverless look at all of those dimensions when it determines how many cores it needs, or is it only looking at CPU?
It generally looks at the number of user connections and the CPU. So and the memory and everything is actually 3 times. So let's say you have 12 cores. If serverless expands to 12 cores, you will have 36 GB of memory. If it goes to 24 cores, you will get 72 GB of memory. That's what it is. And whenever your server is not really active, right? We kind of check if your server is not active. We trim back that memory and give back. So we'll put back you into the minimum vCores that you have. Let's say you have 4 vCores as minimum. We will trim you back to 12 GB memory and 4 vCores.
If you have like 200 concurrent threads running at the same time and they're all really light, is the serverless basically say, my CPU and my
It's not, one is concurrent threads, number of concurrent threads. The other is the amount of CPU usage that's being done with this number of concurrent threads. We just won't take one parameter. We take multiple combination of parameters to really decide how much we need to scale and what would be that scale factor is. Yes, sir.
Question.
Do you have any information on the approximate difference of the provisioned vCore versus the serverless vCore? So if I provision 12 vCores for 30 days,
Okay.
and if I set up a serverless with 12 max, and I run max for 30 days,
Oh,
serverless for 12, about how much is that cost differential there? Is it twice as much on the serverless model, or is it less or more than that?
With the price savings, I believe it's going to be close to like 1.7 times or 1 point something times that of a provisioned compute. Earlier, I think it'll be closer to 2x.
And that cost is also for this intelligence that you are keeping. Like the intelligence is being deployed to really understand, do you need to scale back? Do you need to scale up? For that, we kind of charge you for that intelligence.
I think the net, we see this at scale across all our customers. Hyperscale serverless has actually been growing, quite strongly, even though it's still in preview. I think it's just a reflection of the fact that people are finding deep value because they do have these truly bursty usage scenarios and so on. But if you are running 100% all the time and you are deployed into serverless, it will be a more expensive proposition than provisioned compute.
And at that point of time, I would always suggest you to go for provision compute.
Provision compute.
Yeah, I kind of expected it would be a little more expensive, just wondered about ballpark.
2x is the ballpark. It's going to be a little lower than that with the price savings is
Yeah.
what we believe. Exact numbers can be compared with the pricing calculator when it goes live. But yeah, around that ballpark is what, I mean, the simple analogy, and I use this in other forums, it's like you have your own car versus an Uber or whatever, right? So it's if you do a lot of trips with Uber, those costs quickly going to add up. So yeah.
Yes, sir.
Question.
Pay for, like, before you pay like a SQL license,
Uh-huh.
actual thing. So when you're in serverless and like say it scales to 8, you're going to be paying for 8 core SQL license at 8, right? And then it scale down to 2, you play 2, you pay 8
That's true.
when you do the single license.
Very, very good point. The license cost is baked into the final rate that you get in your bill. The good news is with the new pricing, that cost is going away effectively. Yes.
Yes.
That's how this 35% comes into play. So in the past and in the, like even currently till December 15th, the per vCore rate includes, there is a core vCore component to it, and then there is a meter associated with the software IP cost. Starting December 15th, that cost for the license is gone. Specifically for hyperscale, and this is a business decision. I'm sorry?
Only for hyperscale,
that is true.
yes.
And this is a business decision because we firmly believe that the best performance and the best value for customers will be with hyperscale. With it's built for the future and for the present. And this should be, if nothing else, one more incentive. And I'm not trying to, oversell this thing. It is truly groundbreaking. We firmly believe that if there was any other obstacle, I think this price thing would have been the last thing.
Yeah.
We are trying to remove it.
Yes, yes.
So this is a totally different engine than the SQL Server, right?
No.
Aditya mentioned.
No, it's not. It's the only.
You want to go back to the?
Yeah.
I can try to
Yeah.
rewind while you talk.
Yeah. So it's not any different engine, sir. It's the same exact SQL Server that you know, the 30 years of SQL Server. That's the same engine that you're using.
So it's 100% compatibility, like
Yep.
application from using regular SQL Server to hyperscale.
Yes.
It will be 100%.
Yes. That's what if you see what I have shown you in the updates, when we started, it was not actually equally there because of the distributed storage. We have to cut down few. But we are getting to a point today. We can say proudly that we are almost equivalent to
Yeah.
the own.
Let me put it in a different sense. There are capabilities in Azure SQL database which already exist, right? Like those are 100% what hyperscale has. Capabilities like what Surbi mentioned a little while ago, like if you have to write a query
Cross-database, right.
which accesses two databases, essentially a three-part naming or a cross-database query, those do not exist in any edition in Azure SQL database. Those are typically used when you're coming in from SQL Server on premises or in a VM. So we have SQL managed instance for those cases. So the parity that we have with hyperscale is with, let's say, general purpose or business critical. From a
Yes.
feature. So if you had code that was running in one of those, you can run it in hyperscale, no modifications required, it'll just work. But
Let me paraphrase.
yeah,
So just in case if this application is totally isolated,
sure,
not on any other database,
sure.
you will be 100%.
There are other small but important exceptions. I think the full list is in our thing. For example, if you're using, yeah, it's in the docs. So for example, CLR stored procedures, CLR code. Do you have any of that running in your database? That is not allowed in Azure SQL database. So we have these different types of offerings, right? Like you have VM, you have managed instance, and then you have PaaS, which is what this is. Platform as a service Azure SQL database is meant for those cloud native development scenarios where you've started an application or you have an application which is fairly modern and it doesn't use, for example, CLR, or it doesn't use things like cross-database queries and so on and so forth. For those applications, hyperscale is a PaaS offer, and it will be the same feature set as you had for general purpose, for example. So
And-
so it's not a migration target. If you're coming in from, let's say, VM, you should probably be targeting MI,
Yeah.
managed instance.
And
and so
as Arvind mentioned, there are a couple of them, like Hackathon is one thing that it's not there in Hyperscale today.
Sure. Those
And
are edge
the
cases
Edge
which,
case, very edge cases. But as far as programmability surface
Yep.
is concerned, it's the same programmability surface that you will have in Hyperscale too.
Does it help? Okay.
Just another question.
Sure.
From my perspective, hyperscale is an isolated database, right? You cannot join to the other database.
Yes.
My company. What if I have other database, which is the management instance or standalone database in my company? Can I join the table using the whole part name convention to the hyperscale table?
I believe you can do linked servers to
Hyperscale.
Azure SQL database. What you can't do is set up a linked server from
Hyperscale database back
the other
to,
way.
yeah.
Makes sense. So generally speaking, PaaS, think of the platform as a service model. So it's kind of like a unit of its own, independent and designed pretty much cloud up, ground up for these cloud kind of patterns, where you don't have all the stuff that you used to have with, let's say, an IaaS setup or an on-premises setup. Does that help? No, you can't. You can do
You
the
can
other
do
way
from
around.
on-prem to
MI, if you have MI, you can do a
Link
like a
server back to
to
named replica.
Azure SQL DB in general, including Hyperscale. We actually have some customers who do that. You can. I'm sorry? Yes, you can. The only reason we don't mention it prominently is because that feature still remains in preview, technically speaking, I believe, the Elastic query, and that is the reason why we don't.
Okay.
Slightly, yeah. There
Yeah,
are
that can be
variations
done.
on
Yes,
that,
yes,
and
yes, yes.
I think Hugo from our team actually has a session dedicated to data virtualization.
Yeah.
It's later in this conference, I believe. It's in one of the bigger rooms later this week. Other questions? Thank you for all the interaction. This is really helpful.
This is really good.
Okay, let's keep moving on. Sorry, go ahead.
Go for it.
We'd love to hear.
Do you have any tools how to increment? Let's say I have an application in-house, right? I want to load those data into the.
Sure.
How could I incrementally updating the
Um,
hyperscale database?
If you want to keep them side by side, come talk to us at the booth. So we have this thing called Migration Assistant and Migration Service. There are two ways to get your database from other places into. Go ahead. You want to have a side-by-side approach. Sure. Come talk to us at the booth.
Come talk to us at booth.
You'll probably have to do some
Yeah.
kind of CDC mechanism, and there are options there.
Yeah.
But I think it's best discussed, in detail.
Yeah,
with the
our
booth.
architect Ravinder, he will be there tomorrow.
There
so
are patterns.
he
which you can
has
follow.
done multiple migrations like that, so
Yeah,
he can help.
yeah. This is, Ravinder. So 1:30 p.m. tomorrow, Ravinder and Sudhir. They're going to talk about data integration patterns, I believe, is the theme, right? Data integration is the theme. Okay, I'm going to fast forward and get back on track. So in the meantime, again, thanks for your questions. If you have more,
Arvind?
please let us know.
Time check 23 minutes.
I know. So we'll be good. So Aditya talked about serverless, great for managing unpredictable database workloads, which apply to, let's say, a few databases. As we talked about the pricing differential, like 2x the cost potentially in some cases. When you have a group of databases, let's say tens or hundreds of, or even more of these databases, those costs could potentially rack up. So for those scenarios where you have a larger number of databases, again, they could potentially individually be unpredictable in their workload patterns. We have this great tool. Again, it's a fairly unique capability that we have, which is called an elastic pool. An elastic pool is a way to provision a pre-assigned amount of compute and associated memory and so on to a group of databases. Those databases live in that pool. Just like you can imagine a WAN pool or any other pooling scenario in the real world, it's kind of like you're sharing resources. When you're sharing resources, you obviously have to play by the rules, and you can't have too many players who may eat up more than the available resources in the pool. So to explain this, I have a set of 8 databases. These 8 databases individually have workload patterns which are kind of spiky. They are unpredictable in that sense. But they generally don't overlap. So the analogy is you have a WAN pool with like say 10 people in your community, and any given day only 4 people are really going to work, so they take the WAN pool. At any given time you only have 4 people peaking at the same time or using the resources. So this is kind of like the visual here is intended to depict that when databases are peaking, they don't all peak at the same time. Like the gentleman mentioned, like if I always am at like 100% CPU, then it's a different kind of a challenge. So individually unpredictable workloads, but they don't always overlap. That's the key thing to keep in mind. If you had to optimize these, you could either use serverless, like we did before, or in the provisioned compute case, you'd have to size each of these databases to the maxes that they need, like individual database. So this guy needs this much. Same for here, you'd have to individually right size these databases and potentially be paying for a whole bunch of unused capacity. When you overlay all these individually unpredictable patterns into, like you sum all of them up, you may see a more even workload pattern over time. And that's the whole principle behind which elastic pools have been built, wherein you can say, I can have individually unpredictable workloads, but in aggregate, those workloads become stable, they become kind of much more predictable. And when you have that collective predictability for the workloads, you can then say, I'm going to pre-assign a resource pool, which is what we call an elastic pool, which has an amount of CPU, it has an amount of memory, and it has associated storage with each of these databases. And you can then realize cost optimization. This is kind of like a very dense mathematical thing here, but it's actually very easy if you think about it. In the previous case, I'd have to size each of these databases to their individual maxima or maximums, depending on how you want to spell it. In the case of the pool, you actually take the sum of their individual resource usages, and you have this nice, more even looking chart here. So your costs are built with that total usage pattern in mind and can be much more kind of reasonable. It's a question. It is a multi-tenant scenario. Let me put it this way. Just give me a sorry. So it is a multi-tenant. It is typically applied when your applications are multi-tenant, but you still want the single tenancy of the database. So each database here, this is typically used in a SaaS kind of a model or in an IT services model or in larger enterprises where you want to have different databases for different things. So each database remains isolated. Pool doesn't mean that we unlock cross-database queries, for example. It is just a mechanism to resource pool them together.
But the challenge, or maybe my assumption challenge is like, okay, so then you can keep some US region clients and APAC region clients.
Okay.
Because you know that this guy does the US stock exchange business and other one does the Japan stock.
Sure.
But now the region is different, APAC, US, how do we do that?
That's a very good question. So the question again was, this looks great from the scope of a region. In fact, it's not even the scope of a region, it's the scope of a single logical server in Azure. So you can only pool things together that reside in the same server. So that's a limitation. Longer term, we may have more news to offer in this regard, where the ask is very valid. The ask here is, can I have a resource pooling across my entire fleet, which may be spanning subscriptions, regions, and definitely servers. Right now, it's not possible. Maybe someday in the future, we may have some things to that effect.
Because that flexibility we had in on-prem setup, even though it is SQL Server, you can have, you can set resource governor and give some kind of CPU assignments for those two between those databases of the users and those workloads, and then keep that all the data security. A lot of manual things, but region was not that much in the picture. Because you were in the data center, nobody thought about that, but you were able to create a multi-tenancy and then.
You can still, it's actually the same. Internally, there is RG behind the scenes here as well, resource governance and so on. So it's actually, let me put it very simply, this is no worse or no better in a way. It's better in a way because you don't have to manage all of the nitty-gritty behind resource governor and so on. But it's no fundamental difference between, so even in the SQL Server world, you'd still be constrained by at least that VM running in that one region and so on. So it doesn't change the dynamics. That's true. And because it's managed, you don't have to deal with all the nitty-gritty of resource governance behind the scenes, writing classifier functions and whatnot. So there's a whole lot more ease of use. How many of you use Elastic Pools today by any chance? A couple of hands. So keep in mind, this is a great technique. In fact, there were some people in our team who are of the opinion that by design, you should start off in an Elastic Pool, even if you just had one database, because why not? I mean, you can give the database all the resources in the pool, if so desired. So, and then you can always add to that, add more databases to the pool. So price optimization, cost optimization, Elastic Pools are a great way to save on that kind of a line item expenditure-wise. Questions? Sorry.
So today in Azure, we are able to see like the prediction for the forecast, right? What it seems like it's going to be for demand.
Oh yeah, cost management-wise?
Yes,
Okay,
cost
okay.
management, cost analysis in Azure, like it's
Understood.
but certainly maybe a great point in terms of the region, right? Because virtual machines in other, like if you're expanding to other global regions
Right.
where the currency is not as strong as dollar,
Okay,
the
okay.
demand cost is actually more,
Got it.
but the capability of the client to pay for that
Mhm.
may not be the same.
Mhm.
So I wonder, like, what is the, like, I don't know if there's someone in pricing that could answer this. Like, what is the currency for that? Because in East US is the cheapest region.
Right.
And it's so much more, especially when we go like to Brazil or Switzerland or APAC.
Sure.
If we were trying, like, the point of being the cloud is to be global.
Got it.
So why so much difference of like that?
Okay, that's feedback. Yeah, I think this is something we can kind of note down, and I don't think we are the right people to answer what you're essentially the question was around. Is there a reason? I think it's something to do with the way the cost of doing business in each of those regions is, and so on. But yeah, probably something we can.
We can get back
take it
out. You
offline.
can come meet us in the booth. We can.
I'll just keep
Yeah.
moving on in the interest of time. So here's a quote from one of our current customers. We have a case study published from them who are using pools. They keep adding databases to their fleet all the time. And for them, the most convenient way of handling this is just put it into a pool. Don't have to worry about resource right-sizing it till it's much more mature in its workload patterns, and at which time they could pull it out or keep it in another pool, which is of a different size and so on. Pools have been around for Azure SQL DB for a while, but they had some pretty significant limits. The most significant limit of which was the 4 terabyte storage limit. With Hyperscale Elastic Pools, we do away with that limit. You can go all the way up to 100 terabytes. Again, this is the total size of all your databases in the pool will at the most be 100 terabytes. We have the highest log generation rate. So if you have an ingestion heavy workload, like lots of ETL, lots of bulk inserts into the databases, Hyperscale gives you up to 100 megabytes per second of log ingestion rate. This is independent of the amount of compute you have. Practically speaking, you'll tend to have at least, let's say, 4 week cores, 8 week cores to get to that kind of a rate, but that's a tremendous boost if you compare it with, let's say, other offerings in the cloud. We can scale this pool up and down independent of the amount of data it has. We have scaled databases, we have scaled pools which have like 100 terabyte worth of databases in a matter of minutes. It can go from 80 vCores all the way down to 4 vCores in periods of low usage, and you can scale that back up again to 128 vCores if you wanted to with the new premium series hardware that we have. It is not a size of data operation at all. Same principles as Aditya reinforced up ahead in the beginning of this presentation, completely decoupling compute and storage. Excellent value prop. When you want to optimize over those weekends, holiday periods, you can scale down. When you have a really busy beginning of month, end of month, or a busy event of some kind, scale it back up. We previously had pools in preview. They've been in preview since May 2023. With this event, we have announced, there's a blog post out there, we have announced premium series hardware and memory optimized premium series hardware for pools as well. With premium series hardware, you can go up to 128 vCores for the pool itself. This is huge because again, if you had those workloads which need that kind of compute power, you have it now with premium series. memory optimized premium series is the 2x memory to vCore ratio that we talked about earlier. You'll see a demo of this in action in a minute. And memory optimized premium series could be the best performance that you get for certain workloads which may have a lot of data access. For example, they are analytical in nature, or they're accessing a ton of data, they're doing large aggregates, and so on and so forth. All of these, of course, behind the scenes, they're running on current or latest generation hardware. I want to show you quickly a demo of this in action, and specifically to reinforce the value proposition of memory optimized premium series hardware. So that's what MOPRMS stands for. As a quick recap, memory optimized premium series has an incrementally higher cost than standard or premium series hardware, but it gives you that 2x memory per vCore. So again, think of those workloads which are truly demanding, especially those coming in from, let's say, premium or business critical kind of tiers in Azure SQL DB. This could be a right landing point for it. So my demo starts off with a little recap of what we set up. This is the Azure portal page for an existing hyperscale elastic pool. It's currently set up to use the standard series hardware with 24 vCores of compute. Each database, and this is going to the point that Surabhi made a little while ago about resource governance, I can set a per database cap, a limit, saying no single database in the pool can use more than these many CPUs, which we've set to 6 vCores in this case. You can see the range that it can have, but that's 6 vCores for now. And again, just to reinforce the fact, we have standard series hardware. We are later going to scale this pool to memory optimized premium series, and then we're going to compare the workload characteristics, such as throughput and query execution times. The first part of the demo shows you standard series. Now, this itself is in many cases, if you compare this with other, let's say, general purpose offers, you may see a huge improvement even with standard series hardware, but we'll use that as the baseline. We're using HammerDB, which I'm sure many of you have seen in other places, as a simulator of TPC-H type workload. TPC-H, I think many of you know, is more of an analytical type workload. This particular workload touches a ton of data, and it needs a lot of RAM, and it benefits with a lot of memory as well. You can see the current numbers. We're like, these visuals are kind of indicative. They were taken at a point in time, but you can kind of keep that in mind when we compare it with the memory optimized premium series. The other proof of the pudding, so to speak, behind the scenes is if you look at resource consumption. This is at a database level. We're trying to show you how resource consumption patterns are for that workload. I want to focus on 2 columns here. This column here is the data I/O percentage. You'll see that this workload is exercising the data I/O code path quite heavily. That means it's touching a lot of data. It's reading a lot of data, not just from the local cache, but from these backing paid servers behind the scenes. As a result of all of that I/O, your CPU is being severely underutilized. You're like capping off at around 40% of CPU at the most, and your workload is therefore waiting a lot of time on these data I/O cycles to complete. For those more SQL kind of aware, this is query store. You can see the proof of the pudding again there. A lot of buffer I/O, hardly any CPU waits. That means your workload is heavily bound on accessing the data that it needs. More proof of the pudding again in the Azure portal. This green kind of line here on the top is data I/O. And you can see very quickly it kind of becomes the dominant resource usage pattern for this workload. Eventual proof of the pudding is the numbers. These numbers are a little small, but I can just kind of point out these like 82 seconds. So the HammerDB workload at the end prints out this summary saying how much on an average did this workload take. And this workload, because we're running it on multiple databases, you have to look at the range. So it's typically going anywhere between 82 seconds on an average for each of those 22 queries that it ran, all the way up to like 100 plus seconds, 110 plus seconds in this case. So just keep those numbers in mind we can see how MOPRMS really helps us in this case. The good news is you can scale your existing pool in place from premium series or from standard series to the memory optimized premium series. It's literally in place update operation. Takes 2 minutes, 2 to 3 minutes at the most, and you don't have to move data around even if you had like hundreds of, like 100 terabyte of data behind the scene. Same test configuration parameters, same databases. You can see again TPC-H like workload, These numbers look bigger, great. Let's look at the workload patterns behind the scenes. This is pool level statistics. You can see I'm using a lot more CPU, and data I/O is gone. It's like 0 because everything is hot in the memory and in the local buffer pool extension cache. At the database level, same patterns. The database is no longer I/O bound. It can now fully exercise the CPU for doing those aggregations and computing the results for the TPCH like workload. More proof of the pudding, hardly any data I/O except maybe at the beginning to warm up the caches, and then we're spinning on CPU, which is great to see. This is our analytical workload. We wanted to use CPU. That workload completed in a lot shorter amount of time. The previous run took more than an hour to complete. This is like 15 minutes and it's done. Average query execution times, and this is the clincher for me. Remember, the range for the standard series hardware was like anywhere between 80 to 110 plus seconds. These numbers are very small, but I can show you, I mean, if it's anywhere between 14 seconds to 16 seconds. So you go from 100 plus seconds to 15 seconds. That's a huge benefit if you use the right kind of hardware. Of course, this is a demo, and your workloads in practice may vary, but it just kind of shows you. And it's really speaking, in the end of the day, if you're an experienced SQL Server professional like many of you are, it's not rocket science. You have more memory, the workload runs great. But the great part is, at the right price point, memory optimized premium series for pools allows you to do that in the cloud. Whereas previously, you didn't have that option to scale beyond the current available resource requirements. So that's my clincher for the pools. Let me kind of hand it off to Aditya to kind of tie things up, and then we can take any trailing questions.
So this is awesome, right? So what you are saying is, just by changing the hardware, we got from 82 seconds to almost 12 seconds.
That's
which is like 4 times.
Yep.
Great.
That is
So putting this all together, right? So hyperscale is for your growing business. You start small. You can have 10 GB of data. You can have 2 cores or 4 cores assigned to it. Take a serverless database, play with it, have your database there. You increase your business, hyperscale grows with you. You can put your high availability into a different region. You can have your applications talk to one of these high availability region, and you can increase your storage as it grows. And then your business is awesome. It went through the roof. Now you have read replicas, and with the named replicas, you can put your finance, Power BI, all the analytical reports onto the named replicas, and your application can grow, and hyperscale grows. So you can grow from 10 GB to 100 terabytes. You can grow from 1 core to 80 cores. 128 V cores, and all within no time. So this is what hyperscale powers you. For me, the summary is only 3 bullet points. I want you to go out here with 3 bullet points. First, I will actually start with second and third, and I will come to the first later. Second is, if you are in doubt, please use serverless. If your workload is, you don't know how much your workload is, if it is ballpark, use serverless. You have group of databases, use elastic pools. Take use of MOPRMS hardware, PRMS hardware with elastic pools. Finally, this is what I want you to live with. Hyperscale is the world's best database, and we all want you to see you out there. Okay? Thank you so much. And these are the few recommended sessions we are recommending to you at the pass. Please take a look at it. These are few references that we have for you to take care. And lastly, this is me. That's Arvind. Yep. Those are our social handles. We love to connect with you. Thanks for being great audience. Thank you.
Thanks. We'll be here for more questions, so do feel free to reach out.